Good afternoon, everybody, and thank you for being here. I'm Vanessa Pineda, the engagement lead on INFER and a director at Cultivate Labs. Today, we're going to be discussing how the United States can reassert leadership in microelectronics, a critical part of the nation's ability to gain a competitive edge in artificial intelligence. But before we get started, just a little bit of housekeeping. All attendees' mics are muted. We ask that you remain on mute throughout. We will have a bit of time for questions at the end, so feel free to drop those into the chat and we'll get to as many as we can. Next, I'm honored to introduce our moderator, Beth Sanner. For 35 years, Beth Sanner served in a wide range of leadership, staff, policy, and analytic positions in the Office of the Director of National Intelligence, the CIA, the National Security Council, and the U.S. Department of State. She ended her government career last year, having served as the Deputy Director of National Intelligence for Mission Integration for 2 years, during which she oversaw collection, analysis, and program oversight throughout the intelligence community. In this role, she also was the President's Intelligence Briefer. Previously, Beth was the Director of the President's Daily Brief, Vice Chair of the National Intelligence Council, and a senior leader in CIA's Directorate of Analysis. Today, she's a senior fellow at Harvard University's Belfer Center for Science and International Affairs, a professor in practice at University of Maryland's Applied Research Lab for Intelligence and Security, and a CNN national security analyst. Thank you so much, Beth, for being here. And now I'm going to turn it over to you.
Thanks so much, Vanessa. I'm really happy to be here. And I'm here in my role as a professor of practice at ARLIS. And this is our very first Fireside chat. And it's designed to support our INFER community. And INFER is our ecosystem, that is our forecasting platforms across different levels. And right now we're focusing on S&T issues. And so what we wanted to do was for our forecasters, first, I just want to welcome you and thank you and say how important each and every one of you are. You are really contributing to national security, and I expect that that contribution will grow in the future. So thank you. These sessions are for you, to interest you, to energize you, to educate you. And for those of you who aren't part of our forecasting community, you're very much welcome to join and participate. And perhaps in the future, you'll be interested in joining us in our forecasting endeavors. So today, we just decided to kick off our series, these Fireside Chat series, focusing on semiconductors and microelectronics, because they have been really a focus of a lot of what we've been doing in our forecasting. And it is so important to our national security. And this administration, in a bipartisan effort, has really focused on the importance of U.S. leadership in this sector. And so we invited our guest speaker, Professor Jesus del Alamo, to join us. He is the Donner Professor and Professor in Electrical Engineering at MIT. And he will discuss recommendations he's made from his recent MIT report, Reasserting U.S. Leadership in Microelectronics. I would like to just read briefly his bio, and then we're going to kick it off, and then we hope to have a little bit of Q&A at the end. Professor del Alamo started his education as a telecommunications engineer with a degree from Polytechnic University in Madrid and MS and PhD degrees in electrical engineering from Stanford. He started his career in working in Japan, but has been with the Department of Electrical Engineering and Computer Science at MIT since 1988. He was director of the Microsystems Technology Laboratories at MIT for 6 years. And his current research interests are focused on nanoelectronics based on compound semiconductors and ultra-wide bandgap semiconductors, as well as novel ionic and ferroelectric devices for AI accelerators. Jesus has won numerous awards and other recognition in his field, just too numerous to mention, but he also is currently the editor-in-chief of the IEEE Electron Device Letters. So welcome, Jesus. I'm so glad that you're here.
Thank you, Beth. Thank you. I'm also delighted to be here to talk about this very important topic.
So I wanted to start off just by asking you, how did you get started in this field that's so important now? Back in the 80s, I don't imagine that it was tripping off everybody's tongues.
Actually, it was back in the 70s. As an undergraduate student at Polytechnic University of Madrid, I took a course on semiconductors, and I absolutely loved it. And so then the professor was doing research on solar cells in his lab. So I asked him, could I help out in some way? And so he connected me with a graduate student that was doing his PhD on solar cells. And the rest of my undergraduate years, I did research on solar cells. And eventually I decided that I really wanted to pursue a PhD and that I had to do it in the United States. And that is what brought me to the United States and then to the rest of my career on semiconductors.
Well, I think that all of us are so glad that the innovation in the educational system in the United States was a draw and drew you in. So I thought we would start off first talking about microelectronics and semiconductors and how to think about these phrases, because, for me, I use these interchangeably, but I think that there's more behind what these things are, how to differentiate, and what are the other aspects of this field.
Yeah, they're used interchangeably, and I think that's appropriate. Semiconductor refers to a family of materials with very special properties, of which silicon is the best exponent. And these materials are really at the heart of modern electronics, and also many other very useful devices are made out of semiconductors. Microelectronics refers to the engineering discipline of making devices on a micron scale, and more recently nanoscale, in which we combine many different types of devices to make complex circuits on a very small scale. And that is what eventually results in these microchips that contain millions, in fact, these days, billions of transistors and other devices. And of course, this is all based on the semiconductor itself. So semiconductor, microelectronics, we understand each other. They're both relatively indistinguishable.
So getting more to the heart of the matter of why we're here, I think that there's just been, terrific concern over the last decade, but really accelerating in the past, I would say, really maybe since COVID, and concerns about China and China's rise and its interest in dominating this field and all other technology fields. The US developed semiconductors back in the 50s. We were the center of the universe. And you hear now people talking about, well, only 12% of semiconductors are made in the United States today, down from 40% in 1990. So what's behind this?
Well, at its heart, like in other fields, it's really economics. It's just cheaper to set up fabs and to fabricate chips in Asia. So the cost differential with Taiwan and Korea is approaching 30%. And the cost differential with China is perhaps as much as 40%. So that's the heart of the matter, is cheaper. And therefore, companies will set up facilities there in an extremely competitive environment rather than here.
So what makes it more expensive in the United States?
Yeah. If you analyze the nature of this cost differential, the biggest part of it, almost 3/4, is really government incentives of various kinds, tax incentives, subsidies of various kinds. That's the bulk of it. Governments overseas, particularly in Asia, have really declared these technologies strategic, and they want to dominate them as much as possible. So they're willing to spend tax money and subsidize the setup of fabs overseas. There are other components, but they are comparatively smaller, such as the construction costs and the cost of labor, but really government subsidies is really the key.
That's really different than a lot of industries where labor is the big factor. Yeah. And so when we're looking at this, I guess when we look at a fab being set up in Ireland, the reason that it's going to Ireland is because the Irish government has decided they want it there, and they're willing to subsidize.
Yep. Irish government, perhaps regional governments, local governments. Yep.
So do you think we should be measuring US leadership in semiconductors based on that statistic about where they're manufactured?
Yes, it is really critically important to reshore semiconductor manufacturing into the US. We really should be paying a lot of attention to this. So I think the interest today is very well founded. You know, we have all become aware in the last couple of years of how disruptive certain effects can be. The supply chain disruptions that we have seen due to COVID, but also earlier due to, for example, fires in semiconductor fabs overseas. They ripple through the economy very profoundly because microchips are today everywhere. So we need to minimize that. And one way to minimize that is to really have onshore facilities that we control to some extent. Also, this is an industry that pays good salaries and that provides very good employment. And so today, the average salaries are significantly higher than the average manufacturing salaries in the United States in other industries. And so these are jobs that we should have in the United States. And also, these jobs have a very significant multiplicative effect. Every job in semiconductor manufacturing is believed to generate 6 more jobs across the economy. So this is something that we should really have as much as possible in the United States. I think these days also, tragically, we're becoming aware of how important it is to have unique and very advanced defense systems. And chips are really critical to give us an edge on the performance and capabilities of defense systems. And so this is really essential that we have control and a stable supply of very critical defense chips. And finally, and this is perhaps more subtle, there is a great deal of innovation that is required to bring a new semiconductor technology into high volume manufacturing. That very last step, where you think you have a technology that is ready for commercialization, bringing it up to cost-effective high volume manufacturing is so hard. It requires a great deal of innovation. And that is done wherever the factories are. We want that innovation to be done in the United States. Otherwise, we are going to lose our edge. So that's one more reason to really bring fabs back to the United States. So the focus is very appropriate.
It's kind of like the space program. You know, it's so essential to innovation and things that have happened and jumpstarting us ahead. But it also, you know, I've been reading some things about how environmentally, even though in the end, this kind of microelectronics is so important to environmental solutions, the production of microelectronics semiconductors is also potentially a big drag on economic policies. It uses a lot of water. I read that TSMC in Taiwan uses 5% of Taiwan's energy. How can we square the circle between these kinds of environmental concerns and energy policies?
Yes, this industry requires a lot of water and requires a lot of electricity. And so it has to deal with it. And I think the good news is that the industry is really putting a very high priority in becoming fully sustainable in terms of producing their own electricity so that they don't have to draw from non-renewable resources. And also in, for example, recycling water. And I think there are goals to recycle approaching 100% of the water that the fabs use. So I believe the industry is making a very big effort to make itself significantly more environmental. And in fact, I was looking recently at the 2020 Dow Jones Sustainability Index, which measures the sustainability of some of the biggest companies in the Dow Jones. And there are a number, in fact, the most significant semiconductor companies and semiconductor equipment manufacturers are on that list. So that really shows you that there is a very high priority to address that environmental footprint of the industry.
It seems to me that we also need to be careful just where we put these plants. I know that, for example, up in upstate New York, I think one of the new fabs is going in near a place that has a lot of water. And I still don't completely understand why there's a fab going into Arizona, even if you're doing 100% or 90% recycling of your water. But I'm sure there's some tax interest there or something.
Most likely, yes.
So what are the other aspects of the process and the ecosystem? So we have fabs, but we also have other things that are essential for US leadership. How are we doing on those?
Yeah, that's a very good question, because we all hear about this 11 or 12% share of the US in semiconductor manufacturing and lament the poor situation that the United States has brought itself into. But that's only one aspect, very important aspect, of course, of the semiconductor ecosystem. As it turns out, US companies hold 47% of the global share of semiconductors. So US companies really are by far the number one. The US is the number one country in terms of chip selling, providing chips to various applications around the world. And the issue is that a lot of those chips are actually made overseas. And in fact, the same economic incentives that we were talking about earlier, also have brought US companies to set up fabs overseas. So in fact, 57% of the US owned fab capacity is overseas. So US companies are also responding to those economic incentives of foreign governments and install their fabs in places where they enjoy tax subsidies that are not available in the United States. But the US industry as a whole is really very healthy. There's another area that is very healthy in the United States, which is chip design. So as I said earlier, with 47% of global sales owned by US companies, that means that the chips are designed by US companies and sold by US companies. So that's another area where the US holds tremendous leadership. And one more is the equipment that is used to make the chips. Also there, US companies own, a big chunk of the market, is 41% of global sales or so, way ahead of the next country. And finally, the design tools that are used to design the chips are also made predominantly by US companies. So the ecosystem is very broad, is very rich, and the US overall has a very strong position. So one area where we are weak, extremely important, we have been talking about semiconductor manufacturing. A second area where we are also quite weak is the packaging technology, which is mostly done all overseas. The US has very little packaging in-house. And this is a technology that is likely to become quite significant in the near future that we need to pay a lot of attention to.
What is packaging?
So packaging is, once you make a chip, you cut out the silicon wafer onto tiny chips, then the chip has to be enclosed in a protected environment and then provided with connections to eventually be mounted on electronic boards. That packaging technology is what we are talking about. And so up until now, it has been a relatively low-tech, inexpensive technology, best to be done in low-cost countries. But looking forward, there are new developments in packaging technology that is going to make this process step to add a lot of value to the final product and a lot of functionality, and therefore, and also it's going to require a lot of innovation, and therefore is a technology that now we would like to bring into the United States. So this is in fact a new focus of the government in the CHIPS Act that is being discussed in Washington these days.
Which countries are good at that?
Well, that technology is mostly established. Commercial technology is mostly based in Southeast Asia. In terms of the emerging new packaging technology, which is called heterogeneous integration of chiplets, little chips assembled together in one package, TSMC in Taiwan has set itself up in an extremely strong position. So just as in chip making, TSMC is also has a commanding lead in the new heterogeneous integration packaging technology.
You can see that it would kind of stem from that.
Mm-hmm.
So it's connected. Well, what are the most important things that the US needs to do then in order to be competitive and secure?
So we should focus on the leading edge, where the US has particularly lost leadership, because it is at the leading edge where the profits are the largest. And it's also at the leading edge where you have to deploy a lot more innovation, and you also enable a lot more innovation based on those leading edge technologies. So clearly that should be a key effort. A second key effort is that the US needs to really establish an advanced foundry business with technology also at the leading edge. Essentially what TSMC does today. They are commanding in the world in terms of foundry business. Foundry means that they don't make their own products. They make products for people. So they don't compete with their customers. Customers come in with their chip designs. They make the chip, they fabricate the chips, and then they give them to their customers. And so that's a foundry business that has really been not only an extremely good business, but it has become also very strategic. And you see, since TSMC and to some extent Samsung today control the leading edge foundry business, they control the innovation that is possible in chip design from all the rest of the world. So you have, for example, US startups in the area of AI hardware, a very critical area going forward, that need to prototype their chip designs somewhere. And they would like to prototype them with the leading edge technology. And the only place where they can do this is in Taiwan or in Korea. And if those companies are not interested because they don't see enough business prospect, they will not do it. And therefore, the lack of an advanced foundry technology in the US is limiting the innovation that can be done on many different areas in the US.
So does that mean that TSMC building a plant here, a fab here, does not solve that problem? Because they're still going to be doing work based on their commercial interest. You're saying that somehow there needs to be almost an incubator.
Yes, exactly. We need to have a foundry, a US foundry that is committed, perhaps because the US government has supported their creation, that is committed to supporting innovation in the United States, that is committed to prototyping chips, tentative, that are designed by startups that could really result in altogether new industries in the future.
Can you see a company like Intel, which really wants to do this sort of thing in terms of setting up its own foundry here? Do you see it doing kind of a partnership with universities or the private sector and the government in order to do that? Do you think that's a possibility?
Well, Intel had a false start on our foundry business a number of years ago, and they are now restarting again. I think they have understood, and probably the government might have suggested strongly to them that this is a critical national need to be able to set up a foundry business that is available to the US. So yes, they are creating this, and hopefully, and in fact, I know that they're also making it available for universities to start doing tentative designs. So yes, I'm very pleased that Intel is moving in this direction. And I don't know if that will be enough, but it's clearly a very strong step forward.
So what do you think are some of the biggest barriers or challenges to us getting to some of the things that we've been talking about?
Well, so we've talked about economics already. Another problem is the dearth of talent, human talent. This is really a concern that is being expressed today as we are looking at this significant investment of the government to foster semiconductor manufacturing, is that there's going to be a very significant need for labor at all levels, from technician all the way up to PhDs. And it's not clear that the US is going to be able to produce such a workforce in short time. You know, first of all, the field of STEM, science, technology, and math is not a field that has been particularly thriving in the US among students, but also the majority of students with interest in STEM have been flocking to computer science and to artificial intelligence algorithms. And they are really, staying away from the semiconductor disciplines, such as electrical engineering or material science or chemical engineering. So the availability of human talent is a very big concern for this effort to really come together. And of course, finally, how much money is the government willing to put forward for this? And the time over which the government is going to try to support this field is also important. In my view, this is going to require more money that is being discussed today, and longer sustained effort on the part of the government to really sustain this industry.
I want to come back to that point, but I want to ask, as a parent, I think it's too late for my son who's already going into his junior year in undergrad. But what it seems like this is a pretty lucrative and good field
Yes.
for kids to get up, get into and maybe find careers in. What would you suggest as some paths for parents of kids of different ages in terms of this high employment area?
Well, this is a tremendous field with fantastic career opportunities. So there is no question that in terms of salaries, in terms of the potential growth and the excitement of the industry, this is really a fantastic field. And I suggest to kids and parents to really try to enjoy mathematics and science, and then once they get into college, to really give a good chance to these hardware-based type disciplines, because there are great career prospects in this.
So more engineering and less computer science.
Well, so once they are into a science discipline, yeah, to definitely look at the hardware disciplines as opposed to the software disciplines.
Yeah.
Mhm.
So interesting. So back to this idea of the US spending money, as I mentioned earlier, and you just mentioned, there is this bipartisan support. We have a couple bills in Congress now working its way through the CHIPS Act and the FABs Act, putting together, the CHIPS Act has about $52 billion in it in terms of domestic semiconductor research, design, and manufacturing. Do you think that these direct government incentives alone are going to jumpstart the semiconductor industry? And if not, what else can be done?
It's a step forward, of course, but it's a modest step. I think the effort needs to be sustained, not just these first 5 years that are being discussed, but it has to be sustained beyond that. And hopefully the effort can also be increased. And we need to think in a very strategic way. We should be thinking into the future as opposed to today. So developing the human talent, I think, is really critical for the sustained health of this industry. And so that means, as we have been talking, investing in education, investing in creating research and internship opportunities to students at all levels, so community college, all the way to PhDs, and fostering the creation of new, engaging educational experiences that really students find attractive and engaging. I have the experience here at MIT of creating lab courses, hands-on lab courses that engage students in nanofabrication that are extremely attractive to the students. We have a wonderful new facility at MIT, which is very attractive and very, very visible on campus. And so we have recently created an opportunity for freshmen, first-term freshmen, to fabricate their own solar cells in this facility. And we engaged a number of students in doing this, and they were just exhilarated. They really loved it. And so I am convinced that if we invest, if we put an effort in developing engaging hands-on educational experiences for our students, we will be able to attract many more students to this field. And that is one of the keys for the long-term success of the US in this domain.
So when you wrote your report recently about reasserting US leadership, you talked a lot about universities and the role of universities. You just mentioned in terms of the talent.
Yeah.
But do you want to expound a little bit on that?
Yeah, so if you look at the composition of the semiconductor workforce in the United States, over 50% of all folks that work in the semiconductor industry, which is well in excess of 200,000, have university degrees. So those come through the universities, and we provide them with the basic education that eventually launches their career. So we, just from that point of view alone, universities clearly are very critical. And furthermore, American universities are really envied around the world because they are able to attract the very best students from all over the world. We see that in our graduate programs, where we have just absolutely fantastic students. And so American universities do that because they enjoy very high prestige that comes from a long tradition of fundamental research contribution, and also the launch of many startups and the launch of many very prestigious careers. So So from the workforce alone, universities really are a critical part of the semiconductor ecosystem. But also universities have contributed a lot of fundamental research and a lot of also applied research that eventually finds its way into the marketplace that supports the industry. There are many significant achievements that were demonstrated first in universities and eventually found their way to the marketplace. So that's another key area where the universities play a key role. And finally, and again, also an envy of the world, American universities are a cauldron of startups. The innovation ecosystem that is being created, that has been created, in fact, for some time, around US universities is really a model and the envy of the world. And startups are a very effective way to really translate technologies from a university lab to eventually the real world. And also the training that startups provide to the folks that are working in them is also of immense value for the industry in the long run. So these are just three examples of how essential and how critical universities are to the overall semiconductor ecosystem. And that is why universities should be part of all this discussion and be part of the plan for the US to reassert leadership in this area.
So we've been focused very much on the microelectronics issue, but obviously they fit into a broader ecosystem of advanced technologies. And I wanted to know if you could talk a little bit about other strategic technologies and how they relate to microelectronics, how they interact, and which ones of these are most important from your perspective.
Well, so we've been talking, and mostly the discussion these days is about logic technologies. We talk about microchips, which is sort of everything. But for the most part, is really logic technology, meaning the microprocessors, the brains of modern computing systems, and also they enter into many different kinds of microcontrollers all throughout. But there are many other aspects of microelectronics that are equally fundamental and important. For example, memory technology is also critical in many systems. Also, analog technology, meaning microchips that are able to handle analog signals, continuous signals, which is the way the world actually works, and translate them into digital signals or vice versa, are essential for the interface of the real world with our modern microelectronics. So that's another very critical technology. Power management, electrical power management, is another key technology, particularly at a time when we are very concerned about energy efficiency. We want, the world is becoming more electrified. We are more driven to enhance the energy efficiency of everything that we do. So efficient electrical management is really critical. And so again, that is done with advanced electronics, advanced microelectronics. And finally, another example that I can give is 6G communication technologies. Going forward, that is going to enable all kinds of wonderful new systems and applications around the world. And so again, the key technologies that are based on semiconductors, I could go on. There are so many.
Yeah. I mean, one thing, the analog technologies actually is an area where the US still remains in the lead
Yes.
in terms of semiconductors. So that's good news. What do you see as the next generation of semiconductors? Are there new technologies, right around the corner that the US can leapfrog over the competition?
Yeah, one key area that I've taken an interest in fact, I have already some research activities in my lab at MIT, is new technology for AI, artificial intelligence accelerators, essentially new microchips to enable far more efficient and far faster artificial intelligence engines. So the hardware of artificial intelligence. We've all witnessed in the last few years this extraordinary explosion of capabilities of artificial intelligence systems that are doing seemingly superhuman things, solving incredible problems that humans could not really address in reasonable times. And so there is, of course, tremendous potential for these artificial intelligence algorithms to impact human life in the future. But the bottleneck is really going to be the hardware that implements those algorithms, that on top of which these algorithms run, because they are already running flat out and they consume enormous amounts of energy. So we need far more energy efficient hardware for future artificial intelligence. And that's a key area that I am doing some research on, and there is also some research around the world that is an example of a key new technology that we should be really emphasizing.
So we need those electrical engineers, don't we?
Absolutely, chemical engineers, material scientists.
Yeah,
yep.
right, right, exactly. And some bio too.
Some bio too.
So what would it look like for the US to become a superpower in microelectronics? I guess I'm dreaming a little bit here and pretending that China isn't making all these gains. But are there any encouraging signs that you see along that path?
I think with all this discussion and concerns about this field and how poorly we are done in some dimensions, I think we need to keep a sense of proportion. I am personally extremely optimistic about the prospects of the US to regain leadership in this area and to sustain it. I think there are several factors that the US has that nobody else can match. Our ability to attract the best talent in the world and to provide the best advanced education in the world, that is something very unique. And our ability to foster the creation of startups and to create an environment where they thrive and therefore can very effectively bring new technologies into the world. So I'm very optimistic. I see that the US will continue to remain the magnet of the very best people to come here and will contribute to this industry as it has done in the past.
I'm looking at the chat right now and seeing if we can add in some of the questions. And Gabriela is chatting in from Honduras, and she asked a question that I asked you yesterday about investing more in microelectronic production in Latin America, because I think that, you know, I know labor's not a huge part of it, but I also think that creating value chains in our hemisphere is really important to develop and sustain those societies. Do you think, she says, is there a way that can be done?
Yes, in fact, there is an example. Intel has a plant in Costa Rica, a chip plant in Costa Rica. So that's a living example that this is perfectly possible. In fact, it would be such a wonderful way to help develop the economies of our neighbors on the south, to bring chip plants over there and take advantage of some of the uniqueness that they have, in particularly access to water and probably the labor cost differentials. So yes, that I think being nearby and being close allies to the United States, I think they could be part of a long-term strategy.
Here's another one. How do you think the chambers of commerce in diverse geographic areas of the US, I don't know if you will know this or not, because I'm not familiar with that, could get involved in promoting more companies to invest in the production of microelectronics?
Yeah, that's very specific, and I'm not
sure.
Yeah, again, I think coming back to the issue that we mentioned earlier, that subsidies and economic incentives are really critical for where the fabs are eventually set. That if the chambers of commerce can rally local state governments to support the establishment of chip plants, then that will be effective.
Okay, this one might be more up your alley here. Neuromorphic chips. What are these? I don't know. This person knows. And do you have any knowledge of them? And could you expand a bit on their importance?
Yes, very good question. So in fact, I have been talking earlier in this conversation about artificial intelligence accelerators. And so essentially, neuromorphic chips essentially refer to new computational paradigms that are beyond the traditional logic computation that is based on ones and zeros and switches, which is how all computation is essentially being done today. So with artificial intelligence, because of the nature of the algorithms and the nature of the operations that need to be done, there are concepts for these operations to be done, for example, in the analog domain, as opposed to in the digital domain. And so if we can design devices that can do those operations in the analog domain in an efficient way, that is a very significant potential boom to our ability to do computation. So I don't know if I was interrupted here, but so neuromorphic technology essentially refers to new ways of computation and the new device technology that can implement it, and is a tremendously promising field.
That might actually be my internet. That's the first time
Mhm.
that's happened to me.
Mhm.
Are there other questions? Otherwise, I'm going to go back to more of my own.
We got one through the Q&A panel.
I can see that.
And this individual, so this is from Jed Carroll. Sorry if I'm mispronouncing that. But they asked, can you talk a little bit about there seems to be an American business bias towards soft innovation away from the hard innovation, like semiconductors. And
Mhm.
so what needs to happen in the research and VC funding environment to promote that kind of hard innovation so that we can be competitive with, with the Chinese, et cetera?
Yeah, that is really a terrific question. I think if you look at hardware type startups versus software type startups in general, then the economics once again really strongly favor investment in software startups because the payback time is typically much shorter, and because the investment that is required for them to reach a point where they are profitable it's much lower. So hardware startups really face a very significant challenge, and so what we need is that the venture environment, the venture firms commit themselves to supporting hardware startups. For example, at MIT, there is a venture business that was created explicitly to fund hardware startups. So shunning away from investments in software startups, just stay put, make the investments that are required, and be patient for those investments to eventually go through, because that is what it takes for hardware startups to thrive. So we need to have that commitment on the part of various types of institutions to support hardware startups. Absolutely.
Is there something in the CHIPS Act or the FABs Act that supports that sort of R&D?
The CHIPS Act talks throughout about the need to support startups by creating, as I have just discussed, a venture capital environment that favors investing in startups, and also by facilitating, as I was saying, for example, earlier, the prototyping of startup concepts in a cost-effective way through various fabs, wherever it is required, and also to subsidize the early years of the startups so that they can make very quick progress when the technology is very expensive. So yeah, the CHIPS Act has rightfully a very high priority to fostering startups in the United States.
I see a question that focuses on this idea of the manufacturing, and it said, how important is a bottleneck monopoly is ASML and their lithography equipment?
Oof,
I don't know.
You can think of it. You can think of it as a bottleneck, but you can also think of it as an extraordinary innovation that this company had the patience and the focus and the commitment to carry through over many, many years of research and development that took many billions of dollars. No other company had the faith and the commitment to see this technology through as ASML has done. I think they rightfully deserve the unique position in which they are today. ASML is extremely good terms with all the major semiconductor manufacturers. I don't think it's going to in any way abuse its monopolistic, if you want to call it that way, situation, because the technology is just so critical for the future of this industry. But it's an extraordinary achievement that the technology that ASML has brought into the market in the last few years.
Other than establishing chip manufacturing in the US, can we source the manufacturing of materials locally? Do we have enough of it in the US?
I don't know that field so well. So I don't think I can comment in a smart way about the position of the US in terms of the material supply that are needed for this industry.
There's a question about, you were an editor of a journal that covers all of this. And a question here was about if people want to keep up with the latest developments in the field of microelectronics design and production, what websites or people to follow on Twitter or wherever, can we get that information from you? Maybe you can tell us, but maybe we can also distribute it.
Yeah, I can give some suggestions. You know, like everything else, depending on your educational system and your level of technical sophistication, there are different venues that would be more or less appropriate, right? There are many. So this is an area that is now, fortunately, attracting a lot of attention recently. So there are many good venues out there that are distributing very good information in this area.
Okay, I'm checking through now and seeing. I think you may have answered this one already about how STEM careers focus on microelectronics production can be boosted. You talked a little bit about that it needs to be introduced from community level college, undergrad, and grad. What would be the kinds of things that a community college would do? And are there community colleges out there that focus on training people?
Yes, there are certainly community colleges that have programs that are dedicated to educating technicians for this industry. The type of facilities that one needs to educate students in this area is very expensive. So something that we need to foster is the collaboration between community colleges and nearby universities that have microelectronics facilities, so that the community colleges can run educational programs through the facilities of the universities and provide in that way a more relevant education and also more engaging education. As I was saying earlier, I think in my personal experience as a teacher, the way to enthuse students to look at this field and to consider a career in this field is to really expose them to engaging, exciting, hands-on educational experience, hands-on design, manufacturing, or prototyping educational experiences. That's a direction that I am confident that is very valuable. A second one that I didn't mention is internships. Is really, and this is where the partnership with industry comes in, is the creation of exciting, meaningful internships during the summer or during holidays for students to be exposed to the industry and to be involved in interesting projects that they see the connection of their work with the real world and impacting people's lives.
So I think that the combination with industry is really important in community college. You know, so you can, you know, they identify these people for internships early and they have this kind of in and out training, practical things. That's been the way. And I hope that these new facilities are going to establish some relationships like that.
Yep.
I have another question here about export controls and improving technology security through export controls, especially with academia, where there's not as much of, there hasn't been as much of a focus. I think there is increasingly a focus at universities now on this, but how do we deal with this concern about adversaries being able to obtain this technology without stifling innovation? Big question.
Yeah, that's a very difficult topic, which you probably are in a better place to answer than me. Well, you see, from my perspective in universities, we work at a very early stage on very fundamental concepts, very pre-competitive, very far from actual implementation. And as a result, most of the fundamental research that we do should have and doesn't have export control limitations. It's also very complicated in a university environment to work on technologies that have export control, because we, as we discussed earlier, engage students from all over the world, and we cannot be in a position in which we say, well, to work on this project, you have to have this nationality, you have to show me your passport, and you have to have this nationality. That just doesn't work in a university environment. We need to have an open environment for innovation to thrive. So the best at universities is to really stay away from technologies that are so close to the market that are export control. And I think there's plenty of room for us to do fundamental research without getting there.
Yeah, I think that's true. And I am actually glad that some of the efforts to be monitoring certain nationalities has been toned back and rationalized a little bit in the most recent months, because I don't think that targeting people based on ethnicities is really a very wise thing to do over the long run. And we've got to remember that, you know, the reason that you're here is coming from Spain. So many of the scientists that we have who have been so crucial to American competitiveness and innovation have come here because they want to be part of our system.
Yeah, exactly. Actually, let me add one more thing, Beth, if I may, on this, because it's of some importance. Because the boundary of export control technology is not very well defined.
Yeah.
Then in a university environment, we are becoming too conservative. We don't want to get anywhere close to that boundary because we put ourselves in jeopardy. So what that means is that this is really stifling innovation. If that boundary is too close, and then we are on top of that, an error band for us not to get into, then that means that the area, the space in which we can work and that we can therefore innovate is much more limited, which is not desirable. So this is something that the government and the intelligence community should really think very carefully about where to put that boundary as it comes from fundamental research.
Yeah. And I think that having these partnerships where we're actually engaging with academia and saying, we want you to be doing X, Y, and Z, you should be doing that is so important. But it's hard because there's a limited number of people in the government who are, you know, really engaged at this level. And I hope that, you know, I see very positive signs of improving and expanding our S&T workforce throughout the whole government.
Mm-hmm.
Here's a question that I think will be our last question, maybe. Oh, maybe two here. Could the US achieve a 1 nanometer, that's NM, right? Chip, I always just read these things, I never say them out loud, developed domestically in the US?
Oh, most surely, absolutely. I think, but first of all, you have to realize that when we talk about 7, 5, 3, 2, etc. nanometers, it doesn't mean that the critical dimension of the device is that number. This is the use of those labels have a history, and they stopped being related to the size of things now many years ago. But still, we're using those terms. They have some meaning in the industry. We are now seeing 3 nanometer technology being rolled out, and the cadence is for 2 and 1.5, or eventually 1 to come in a few years. And I think the path today of semiconductor industry in the US and overseas is definitely that we will get there. The industry will be there, and the technology at 1 nanometers will be absolutely fantastic.
All right, so I am going to look here, one more thing. The US has general research and design tax incentives. What kind are needed for design tax incentives? Let's see, what kind of design tax incentives do US semiconductor companies need beyond the general R&D tax incentives? Sorry, I butchered that.
That's very specific for me to be able to answer. My gut reaction, but again, I speak from almost complete ignorance, is that the US is leader in the world as it comes to chip design, and probably we do not need tax incentives beyond perhaps those that exist today. I think those incentives are much better used to foster semiconductor manufacturing and to foster creating a leadership position in future technologies.
Yeah, I think that this idea, and we're kind of in this space in 5G and 6G, and you know, where should we be? Things move so quickly, so trying to go backwards and catch up is much less productive than trying to jump into and be ahead in the next thing.
Actually, if I may finish, Beth, there's a great analogy that one of my colleagues often uses, which is that if we were in the 60s today, we might be discussing how to reassert US leadership in vacuum tube technology. You know, a technology that was definitely on the way out, instead of focusing on the emerging technology at that time, which was the microelectronics technology. Fortunately, we didn't do that. But that is an interesting reflection for where we are today and where we might want to focus. It's really critical that we don't get distracted from all this current chip crisis, from making sure that we own the future, because that's where it's all going to happen.
Well, I would like to end it with that note and pull back your optimism that you mentioned earlier. And I think that leaves us in a really good place to conclude this today. I just want to thank you for being part of our inaugural Fireside Chat. I hope that the participants really enjoyed it and felt that it was worthwhile. I certainly learned a ton, and we just appreciate your time and kicking off this series. And for those of you who participated, I want to just offer out to you the opportunity to suggest topics or even people that you think should be featured in future Fireside Chats. And if you think that there's changes to the format or anything, because this is for our INFER community and our guests, and we want to make this worthwhile for you.
Thank you.
Thank you.
Thank you, Beth, for a great conversation.
Great. Over to Vanessa.
Thank you, Beth, and thank you, Jesus, so much for joining us. I don't have anything else to say. I think you ended it perfectly. With that, thank you, everybody, for attending and taking the time to be here.